All right, so we've got rational exponents, so we're going to talk about that. It's going to be a little bit like yesterday where there's only a couple of examples in the notes, but then I'm going to do just a few more. And we will have a stat box. So write that stat box down, and then we're going to come and talk about rational exponents. Now, you should have done some of this stuff last year in trig, but I'm going to give you a nice reminder today before I let you loose on your assignment. So what are rational exponents? Those are exponents which are written as a fraction. So that word ratio is in rational. That's kind of our signal. We know ratios when we compare two quantities, a ratio looks like a fraction much of the time. So that just means that today our exponents will also sometimes be fractions. The exponent laws can be applied to rational exponents as well. So everything we talked about yesterday is still true, and we need to continue to use those laws as we move forward today when we talk about rational exponents. And so we're going to get a couple of slides that kind of go over where this is coming from. And so you don't necessarily have to write these next ones down, but it just kind of gets us thinking of like where it is coming from, and then we'll get the stuff that you need to make sure is in your notes. So again, I don't know that you need to write this down, but this is kind of talking about where this is coming from. Let's say that I've got these two expressions. I have the base of a in both of them, raised to the 1/2 power. What do I do if I want to combine this? What do I have to do to those powers? Add them up. So 1/2 plus 1/2 is 1. And so we know when we multiply something by the same exact thing, that's called squaring, right? So if we square it, we end up with a, which kind of leads into this next part. And I see some people writing, so I'm going to slow down. Again, this is just kind of an explanation of where this is all coming from. So a to the 1/2 is the same as the square root. And so what we're going to do today is be going back and forth. There will be some times where it'll be more advantageous for us to leave it in the square root or change it to the square root. But there will be other times where we're going to need to take that square root and change it into a rational exponent. So keep in mind that if you don't see any number here, it's like an invisible 2. You guys all know that, right? But I just wanted to kind of bring that back as a little reminder. Because, again, this is another kind of example that shows where it's coming from. You may not need to write this down, but just kind of take a look. If I have 4 of these a's, all to the 1/4 power, just like on that last one, then we've got to add that up. And so if I add 1/4 plus 1/4 plus 1/4 plus 1/4, that's going to be 1. So it kind of shows that a to the 1/4 power goes along with the 4th root of a. So just kind of showing where that stuff is coming from is that these roots can be written as that rational exponent. So the next slide is what you absolutely want to put in your notes to make sure you have. It's going to be like the general form. These ones were just examples of where it's come from. This we absolutely need. So if I have a to the 1/n power, it's the same as, I don't want to zoom in quite so much, but I can't kind of get it in between. So if I've got 1/n, it's going to be the same as the nth root. So whatever number is here in your radical, whether it's 2 or 5 or 17, it always goes to the denominator. So whatever is in the radical part will go to the denominator. And it even works also if you've got like a power situation, whatever is in the numerator becomes a power. So like if I have whatever root, and then I've got a base raised to a power, the power goes in the numerator, and then the root, the radical, goes in the denominator, and that is what you definitely need to have in your notes, star it, circle it, whatever you need to do so that you know that that's a really big important piece. Make sure you do it. Is this stuff right here looking familiar? Hopefully. So what we'll do is we're going to take a look at how we can, like I said, use this in a few different types of examples. So it's always like the power over the rut. All right, so just 2 examples here, and then we are going to do a couple more after that. So the first one, we were working on this type of example yesterday. We want to write as a single power of 3. So we're going to write as a single power of 3. So what is the power on that 3 that I just circled? What's the exponent on that one? A 1. And that 1's invisible, but sometimes it's nice to see it. So that's 3 to the first power. And now I want to take that square root of 3, and I want to make it so that it's got a rational exponent. Now I know when I don't see a square there, that's going to be a 2, so I can change this to being 3 to the 1/2. So like I take that 2, remember it goes in the denominator. There's no power except for maybe an invisible 1, if that helps you out. So that's 3 to the 1/2. So again, you don't always need to have this 1 here, but some people forget it if they don't see it. We've got like 1 more step before we finish this one off. Are there any questions? So if I'm multiplying 2 expressions with the same base, what do I do with my exponents? Add them up. So I have to do 1 plus 1/2. And do note that these are rational exponents. That means I don't want a decimal. I don't want you to put 1.5. I don't want you to put 1 and 1/2. We have to write it just as a normal fraction, even if it's improper. So it's going to be 3/2. So just keep that in mind. We don't want 1 and 1/2. We don't want 1.5. We want to keep that as just a plain old fraction, even if it's improper. And then I'm done. But are there any questions about any of that? All right, so another example before the stat box is write in simplest rational form. So I have 8 to the 5/3 power. And on some of these, you might have to play around a little bit and kind of take a look at, okay, like what might work. So you might start something, it might not work, and then you might have to backtrack and try something else. So I'm going to kind of lead us through this because I know that the 3 means I've got a cubed root. So I've got a cubed root of 8. But then I also have to have everything to the 5th power, and it's okay either way we have that. That one will work out. Does anyone know what the cubed root of 8 is? It's 2. So then I've got 2 to the 5th power, and I know there are a few on your assignment that actually say, like, do without a calculator, so keep that in mind that we want to be able to show these steps. Does anyone know what 2 to the 5th power is? 32. So, again, I know when I first approached that, I kind of tried something different, so you might want to try a couple of things before you get there. Are there questions? I feel like we might have questions that we just don't feel like asking. So I can't answer the questions that don't get asked because I don't actually read minds. So are there any questions? Please hear me when I say, like, you might have to try a couple things and backtrack. Like, it might not go, one way at first. Feel free to try some stuff. The stat box is a little weird, and then we are going to do 2 more examples. So in the stat box, kind of ignore this part for a second. I just wanted you guys to write that, like, little formula again and make sure you know that, like, A is the power, the top part's the power, and the bottom part is the root. So just I want that in your stat box so you can turn to that page and you can see that. And I was kind of torn about this. So don't necessarily write that in your stat box, okay? But if you are having any struggles or if you want to get even quicker with this, it would be a pretty good idea to write down the first 5 powers of 2, 3, 5, and 7. We come back to those a lot. So if you have those memorized, or even if not completely memorized, but just like a general feeling of like, I think that's a power of 7 or a power of 3 or a power of 5, it will help you moving forward. So if you've got some space in your notes or in the margin or anything, just kind of write those down for yourself. That will help. It's helpful. So does that make sense? Like it kind of helps. And now hopefully I'll get this erased. We're gonna do just a couple more examples before we get to the assignment because I feel like we need them. We're going to do 2 examples that go like this. Write the following in the form a to the x when a is a prime number and x is rational. So we're just going to do 2 examples like this. The first one we're going to do is the 5th root of 125. I didn't want you guys to get to these and kind of not know how to handle it. So we're gonna write in the form a to the x power when a is a prime number and x is rational. So our final answer will look like this. It'll be some prime number and then some kind of exponent. So that's why I said on that last thing to get to know your 2, 3, 4, or 2, 3, 5, and 7, like those powers, because that's the kind of stuff this is going back to. Most of our answers we're going to bring back to a power of 2, a power of 3, a power of 5, or a power of 7. And so, taking a look at this, 125, what do you think that is a power of? 2, 3, 5, or 7? 5 to what power? 5 to the 3rd power. Good. Now, you can play around if you need to on a calculator. But, we can make that work out. So I've got the 5th root, and I'm just going to change 125 to 5 to the 3rd power. I guess I probably don't need those parentheses. I'm a little parentheses happy sometimes. So I'm not quite there yet, but I've got at least my base that's a prime number. It's 5. Now, what can I do with the 5th root so that instead of having a root, I've got a power? 5 in the denominator. So I'm going to take it slow. So I still have 5 to the 3rd power, but I'm going to change this and make it to the 1/5 with, again, that root goes to the denominator. So just to kind of recap, we figured out, okay, what base should we use? We should go with 5, and then we switched our root to a power. And now we have one more step based on the properties we talked about yesterday, or the laws. When I've got a power to a power, what do I do with those 2 numbers? Multiply them. And so make sure we kind of work on those differences. It's really easy to make some small mistakes there. When we multiply those, 3 times 1/5 is 3/5. And that's my final answer. It's in this form because I've got a prime number for a base. And my exponent is a fraction. It's rational because integers are also rational. So it doesn't have to be a fraction, but it should be a fraction or a whole number. I felt like I slowed it down. Which shortcut?
Put 3 on top of 5.
Oh, go from here to here?
Yeah.
You probably could. But I didn't want to take that. I didn't want to skip that step. But I'm okay with you skipping it. Does that make sense? Sometimes I do things a little bit longer just so that everyone knows all those steps. Because not everyone does different things in their mind, Alright, so let's see if you guys can do this one. Same directions. We're going to write it in that form, a to the x, but it is 1 over the cubed root of 49. So I'm going to give you guys a second to kind of take a look at this. Fraction anymore, right? Just a to the x. I'm missing just a little bit here because 49 is 7 to what power?
Oh, yeah.
So a is 2 and then the negative goes on the power, not out front, okay? So I'm going to flip it, so it should be 2 over 3. What goes in this mouth? Yeah. Everything's perfect so far. Switch that 3 into being a fraction instead. Switch the root into a power. Now bring it up so it's just a number to a power, not a fraction. Wait, so this is right. Don't switch that order when you bring it up. Just leave it there. This is okay. Yeah. Oh, in the song. This kind of came up in second hour. Someone in second hour had a really good idea, and I've been using it with you guys so far today. I think if you're like, I don't know what to do, the first thing you should do is look to see what base am I going to use. Is it going to be 2, 3, 5, or 7? So if you're kind of panicking, start there. So goodbye, Prezi. Apparently we have an interrupted internet here. This should still be okay though. Alright, you guys already wrote the directions down, so I'm just going to write the problem down, right? It was 1 over the cube of 49. Alright, so how can we switch 49? 49, what are we going to use? 2, 3, 5, or 7? 7. 7 to what power? 7 to the second power. So I've got But still everything's the same. I'm going step by step. I'm not trying to do too many steps at once here. Okay, so let's say you get that far. Are we okay on that far? We're like, I don't know what to do next. Get rid of your radical. So whatever your radical is, switch it to being the power. And keep in mind that this goes in the denominator. So I'd have 1 over 7 to the 2/3. Right? We talked about how the root goes in the denominator. And the 2 is still there. So that's you called me out for not skipping that stuff in the last one, right? So I really was trying to go slow, so I did kind of skip it this time. Are we okay with that?
I think it's easier when you just do it that way.
Okay, so I was too slow. So 8th hour, skip the steps is what you're telling me? Okay. Now, I do want this, so it's just a to the x with no fraction. So how do I bring that up? Or when I bring that up, what happens? Negative 2/3. I know that I'm not like writing down steps like first do this, second do this, but I'm trying to say them out loud, and keep in mind these notes are your notes. So if you want to add to your notes and say, hey, first check for this, second do that, please do. And I will make a note to skip that step because we don't need to do it. All right, here's your assignment. Now, it is also super important on some of these sections where we're not like heavy in examples, when the notes are really light, it's even more important to do your homework every night and check your answers to come in with questions. I just need to say that, like, you got to do practice to get better at anything. And with